You've seen it. We all have. The sky gets dark, you hear that rumble, and then bam! A brilliant flash of light just tears through the clouds. It's a familiar sight, right? Powerful for sure. But what if I told you that in that one split-second flash, the air gets hotter than the surface of our own sun? Yeah. Okay, let's get into this. Just take a look at this. On the left, we've got the sun's surface temperature, a blistering 5,500 degrees Celsius. We think of that as like the ultimate benchmark for heat, right? But now, look to the right. A single bolt of lightning clocks in at almost 30,000 degrees Celsius. It is not even in the same league. The difference is just staggering. That's right. To put it as plainly as possible, for that brief moment, a bolt of lightning is 5 times hotter than the surface of the sun. Just let that sink in for a second. 5 times. So let's really unpack that number. I mean, what does a temperature that high even mean? And more importantly, how is it even possible? You know, what's really mind-blowing isn't just the raw temperature, it's the concentration of all that energy. The sun is this enormous star, right? But a lightning bolt manages to pack 5 times its surface temperature into a little channel of air that's only a few centimeters wide. That is an absolutely insane amount of power focused on one tiny spot. Well, this brings us to the big question. How on earth does our own atmosphere cook up something so incredibly hot? To figure that out, we need to look at the anatomy of the bolt itself, the actual science behind the flash. It all happens in this ridiculously fast 4-step process. First, you get charge separation. Inside a storm cloud, ice and water particles are just smashing into each other, creating this massive electrical imbalance. Then comes the air breakdown. That charge difference gets so huge that the air, which normally acts as an insulator, just can't take it anymore. And that opens the floodgates for the electron race, where a massive surge of electrons bolts through this newly created path. And that race, well, that's what leads to the final step, superheating. And here's what's happening at a microscopic level. As those billions of electrons are surging down, they are slamming into the nitrogen and oxygen molecules in the air. We're not talking about a gentle nudge here. These are violent, high-speed collisions that transfer a ridiculous amount of energy, forcing the air itself to glow white-hot. That blinding flash that we see, that is the air being superheated to an impossible temperature. Okay, so we've got the insane temperature and the science down. But what does all that energy actually do when it hits the ground? Because this is way more than just a light show. This is where lightning becomes a force that can literally reshape our world. And here's a perfect, almost alien example of its power. When lightning hits sand or certain types of soil, that intense heat instantly melts the grains, fusing them together into these hollow, glassy tubes called fulgurites. They're literally fossilized lightning, a permanent physical record of the path a bolt took through the earth. How cool is that? But of course, with that kind of power comes immense danger. This is the exact same energy that can cause severe burns, ignite devastating wildfires that can clear entire forests, and completely fry our electrical systems in the blink of an eye. It's a raw, untamable force of nature that absolutely demands our respect. But here's the twist. This incredible destructive force is also a powerful creator. That extreme heat is one of nature's main ways of fixing nitrogen from the atmosphere. It takes the nitrogen in the air, which plants can't use, and converts it into compounds that act as a natural fertilizer for the soil, supporting all kinds of life. Which brings us to a pretty fascinating question, doesn't it? With the power to both obliterate and to create, is lightning a foe or is it a friend? The answer, as it so often is with nature, isn't that simple. It's both. And that brings us to this final fascinating idea. Lightning is both creator and destroyer, a perfect example of the paradoxes that power our world. And this really just sums up that duality perfectly. On one hand, yeah, it's a destructive force, a deadly hazard that can ignite and destroy. But on the other hand, it's a life-giving spark, a vital process that fertilizes the planet and sustains entire ecosystems. And for scientists, it gets even cooler. Every single bolt of lightning is basically a natural particle accelerator. It supercharges particles in ways we struggle to replicate here on Earth. So each flash becomes this fleeting, perfect little laboratory for studying how matter and energy behave under the most extreme conditions you can imagine.
In the end, it really leaves you with this powerful thought. A lightning strike is so much more than just a storm. It really is a fleeting glimpse of the extraordinary energy that surrounds and sustains life on Earth. A beautiful, terrifying, and absolutely essential fire from the sky.